Welcome to the Real Python Podcast. This is episode 220. How do you take advantage of Git pre-commit hooks? How do you build custom software checks and rules that run every time you commit your code? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We share a trio of articles by previous guest Stefanie Molin about Git pre-commit hooks. Across the series, she provides step-by-step instructions for building your own hooks, managing them, and learning how they operate. We discuss the process of estimating software development projects. We dig into the art of guesstimation, rough calculation, and napkin math. Christopher shares his experience in agile scenarios and measuring projects by story counts. We share several other articles and projects from the Python community, including a news roundup, 10 Python programming optimization techniques, building a blog in Django using GraphQL and Vue, experimenting with Python's Preprocessor, a little toolkit for using UIs in PyScript, and a couple of projects for working with the django-admin. This episode is brought to you by InfluxData. InfluxDB is a purpose-built time series platform for ingesting, storing, and analyzing metrics, events, and logs with sub-second query responses and high interoperability. Start now at influxdata.com. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Chris, welcome back.
Hey there.
All right, so we're diving in with our typical layout here, some news, topics, projects, and maybe a smaller discussion depending on how far it goes. Are you ready to dig in?
Yeah, sure. I'll start out with two short bits of self-indulgent, aren't we all great because we code Python kind of news.
Yeah.
First off is the IEEE has done their annual language survey for 2024. I'm pretty sure 2024 is not over yet. I don't know why they do it in the middle of the year, but the end result is Python is rated as number one and not even close.
Oh, wow.
Their normalization was almost double the score for JavaScript. So yay us, I guess. And second is the 2023 Python Developers Survey. So that's the other way around. That was, it seems like so long ago. This was done by the PSF and JetBrains, and the results are out. Since there's nothing much drier than two old men reading statistics, not that it stopped us before, I'm going to skip the results here, but we'll point to things in the links. And if you're curious about who makes up Pythonistas and what tools are popular, then you should check it out.
Yeah. Sounds like it has like 25,000 responses. So good.
There's a nice little, and for the data geeks, there's enough data in there. You can go crunch on it. There's almost always articles pop up afterwards. It's like, oh, here's more information that they didn't show in their graphs.
Yeah, totally. All right. Well, I guess that gets us right into topics then. This one is from Stefanie Molin, who was a previous guest. We actually talked about this a little bit on the show when she was on, about pre-commit and pre-commit, using Git and pre-commit hooks to do all kinds of different things. But it's interesting, when I initially picked this one, it was the most recent one, and then she published something like within days after that. And so I wanted to make sure I included it. And then I went back and found yet another article. So I'm going to mention 3 articles. I'm not going to go into all details on all of them. 2 of them are step-by-step guides, which I think is probably the best approach if you're not familiar with working with Git and pre-commit. They'll get you up to speed. She has been writing about this stuff on her blog for a little while, and also has done a few workshops on this. And I think she does them at conferences. So she's definitely got some practice. So the one I was going to talk about initially was titled How Pre-Commit Works. And that one is probably the most sort of Git side of the house sort of stuff. And it's very, very technical on what's happening in the folder structure and stuff like that. But I want to take it back to an article she did in March that's titled How to Set Up Pre-Commit Hooks. And I'll include a link for that. Also, it's a step-by-step guide to installing, configuring pre-commit hooks on your project. The other one I'm going to mention is called How to Create a Pre-Commit Hook. So they all kind of sound the same, which is a little confusing, but they are dealing with different specific stuff. So I'll try to clarify that a little bit. Again, talking a little bit about the workshops and conferences and the time she came on the show, she was talking about how she was getting involved in open source and got involved with a project that is called NumPy doc validation, which is a hook. Basically, it checks the doc screens within your code to make sure that they follow NumPy doc style, the style guide for NumPy doc. And so she also mentions another project that I'm guessing maybe it's about the same time, but it's called EXIF, EXIF stripper, which it basically removes that EXIF metadata from images before they go into version control, which is actually a really good example of something you may want a pre-commit hook for. So pre-commit hooks are code chunks that are going to run as part of this pre-commit stage when you type git commit. And if any of the checks fail, Git will abort the commit, and at which point you can then address the cause. And so she talks about, well, what makes a good hook? Not every code quality check is going to be a good fit for that. Often people talk about like running something like the rough tool that we've talked about a lot here, which is like a linter, plus it also does code formatting and things like that. In this first one that was about how to set up pre-commit hooks, she walks through using the Python package, which is called, you can pip install it pre-commit to set up your hooks. And she specifies that they don't have to work on just Python files. It can be, something beyond that. It can be looking to make sure that all the other files that are getting committed to a repo are set up properly, things like a TOML file or a YAML file or other things that can be following there. So it's not a Python specific thing. It's a Git thing. She provides a template so you can follow along with it. The one that I'm mentioning here, this first of the batch, was how to set up pre-commit hooks, is step-by-step. And so lots of code examples for you to practice and follow along. You get to learn where all this ties into where a PyProject TOML file is. And then this YAML file that you configure, which is called the pre-commit-config YAML file. She also provides a pre-commit troubleshooting guide, which is another resource that she has there. So that's that article. The second one in the batch that I want to talk about is called How to Create a Pre-Commit Hook. That one is really recent. And this one is much more in Python as far as the way it's written out. It's actually talking about looking into specific rules that you can create in Python code. And so she talks about what makes a good hook. And then she shares her own sort of hook recipe, which starts with designing the check function, wrapping the function in a CLI, and then making it installable. And then again, creating that pre-commit hooks YAML file that we mentioned before. So this time she has an example that you're creating, which is checking file names and making sure that they're consistent. Maybe you have certain rules within an organization, how things need to be named and structured and so forth. And then the third piece is the one I kind of started with, which was from mid-August, and it's called How Pre-Commit Works. And it takes you behind the scenes on the Git side of everything. So what actually happened when you ran pre-commit install and why you had to run it in the first place. How does pre-commit actually work with inside Git? So there is a whole hooks system, not just the pre-commit part. And there's a bunch of folders that are created. So she provides, again, samples and example files. And I like that she includes lots of nice code, not only samples, but like running the code and the sort of errors and things that might pop that you might see as you kind of walk through it. So here you go, a whole bunch of resources if you're interested at all in running checks on your code and sort of automating that whole process. And so thanks again for all these resources, Stefanie.
Yeah, this is a really powerful tool, and it's it's a subtle thing, but one of the things I like about it is you don't need all the rest of the fancy stuff.
Yeah, necessarily,
because it all runs locally, right? So for things that even if you're a solo coder, if there's things that you want to be running on a regular basis, you have to I have to remember to do that. Sticking it inside the pre-commit guarantees that it happens before it ends up in the repo, right? So you can get sort of a poorer version of CI/CD, and you can get an awful lot of the power of that without having to set up the server side stuff and GitHub Actions or whatever else. So it's It's a good, strong first step.
Cool. So what's your first one?
I've got an article, a real Python tutorial called Build a Blog Using Django, GraphQL, and Vue, which is by Philip Axeny. This is a project-based tutorial with step-by-step instructions on how to put together a blogging platform. So it guides you through the use of Django with a Graphene backend. Graphene is a GraphQL library, which if you're not familiar, it's an alternate way of doing APIs. The most common way of doing APIs is REST, which uses a URL corresponding to a thing and an HTTP method corresponding to an action, like, say, fetching a thing. Whereas GraphQL works differently. It uses a single endpoint, and then you construct a query using a JSON-like looking language, which then specifies both what to fetch and which attributes on the thing being fetched that you're interested in. So Graphene's the most popular of the GraphQL libraries for Django. But not that long ago, in fact, in episode 215, we talked about Strawberry, which is a fast API-inspired alternative. So if you're really into this, you might want to go dig that episode up as well. The first step in the tutorial is getting Django installed and the administrative stuff like setting up a super user. And then step 2 concentrates on the models in the database that will represent your blogging content. So your user profile, a blog post, the tags, that kind of good stuff. Once you've got the models, you add in the Django admin code so that you can use the backend to create posts in your blog. So far, this is the typical get started with Django kind of thing. Normally at this stage, you'd then add some views to see the posts. But this tutorial instead uses Vue.js. This is going to get confusing because it's Vue and Vue.js.
Yeah, spelled differently.
Vue, Vue.js for the front end. So your vanilla Django Vue isn't the next step here. Vue.js is a lighter weight front-end JavaScript library that allows you to trigger API calls based on changes to the DOM in the HTML. I say lighter weight because it solves many of the same problems that, say, React or Angular would, but it doesn't take an all-or-nothing approach. React and Angular pretty much need you to have the whole front end be React or Angular, whereas Vue.js can be shimmed into HTML. And that makes it a great choice for working with Django. It allows you to sort of keep some of your Web 1.0 style pages when you want, when it's appropriate, and then sprinkle Vue.js in to be more dynamic. Before I discovered HTMX, Vue.js was my go-to. It maps to Django very nicely. In order to use Vue.js, you need an API on the server side that it will interact with to generate a page. And that's where Graphene and GraphQL comes in. So the next step in the tutorial walks you through how to define the available queries on the server side based on the parts of the database models that you want to make available. You can test Graphene out using its built-in query interface, so you can check whether or not your query code works before you even wire in any of the Vue.js. And the last few steps are then the actual front end, and it shows you how to get Vue.js working, how to write some HTML that works with GraphQL, and also talks about an add-on Vue.js library called Apollo, which makes working with GraphQL easier. So if you're new to Django, this is an interesting place to start. Or if you're old hat at Django but want to learn more about, say, GraphQL or single-page-like applications, this tutorial is a great place to augment your knowledge.
Nice. Philip's been busy.
Yes.
Developers love InfluxDB because it excels in real-time performance for time series data, offering sub-second query responses and scalable architecture. It separates storage and compute using cost-effective Apache Parquet files to slash storage costs significantly. Its open architecture allows direct access to data for analytics, business intelligence, and machine learning, eliminating complex ETL needs. Learn more at InfluxData.com. That's INFLUXDATA.com. My next one is a post on the dev community site. It's by James Ononiu. It's titled 10 Python Programming Optimization Techniques. I found this piece to be really interesting. There's a few different reasons. Many of the techniques are things that we have deeper dives on here at Real Python. And so I'll mention a few of those as I go through it. I'll include links to the courses or tutorials in the show notes for you to dig into further. But one of the themes that I wonder about with all these techniques is, when is it time to do this optimization? And there's the whole
last
yeah,
is
right.
the answer.
There's the whole premature and the root of all evil of it and all that sort of stuff. Does this situation warrant it? And I feel like many of the memory use examples would have a lot more impact if you had large data uses, but the examples that are shown in the code are very simple and sort of toy-like. And so it's kind of hard to get like an idea of it. So not a grain of salt, but like an entire shaker of salt as you look at this article to think about it in this case. So along with that, a big part of it to avoid sort of prematurely doing this is that we talked about performance a lot. We talked to Pablo Galindo Salgado in episode 128 about the whole idea of using a memory profiler. I also talked with Emery Berger about in 172, this tool called Scalene that actually is a kind of a neat one that can actually do much more pinpointing to actual like areas of code. But there's also the problem that when you go to optimize thing, does it make your code harder to parse? It's going to be definitely less of the whole Python explicit kind of thing. Will it be harder to maintain? So again, approach this article as it's a set of tools. It's a toolkit that you could potentially use in these circumstances, especially if you're starting to feel like there's some kind of performance problem happening. So there's two that I have not explored myself in coding, and I think they're kind of interesting. It's the first one that's mentioned, which is called variable packing. You can group multiple data items into a singular structure, and it minimizes memory use. Use case is about memory access times. It could significantly impact the performance of getting faster data retrieval, packing integers into like a compact binary format. It uses struct and a method called pack and unpack. It has to be imported from that built-in library to do this. So that one I'm kind of intrigued by. I haven't tried it, but again, I don't think it's going to make a big difference if it's just a handful of integers you're dealing with. That it would probably have to be a much larger sort of memory structure, I think.
Yeah, those tools usually get used for like pushing bytes down onto network wires or whatever, right? Like it's to go from like a 32-bit integer to an 8-bit integer because the packet expects an 8-bit integer. But of course, if you've only got an 8-bit integer, in theory, you can save a whole bunch of memory by getting rid of it. So it works, but it wouldn't be my first go-to.
Yeah. The third one is similar. It's fixed length versus variable length variables, which is kind of weird to say, but the idea that using Python's array instead of using Python's built-in dynamic list. I'll just read from the Python docs about array. It defines objects which can compactly represent an array of basic values, characters, integers, floating point numbers. Arrays are sequence types and behave a lot like lists, except that the type of objects that are stored in there is constrained. You have to pick what type you want in it. So it's not going to give that variable functionality or that dynamic features of a list. So you specify the type and you use like you could say, I want these to all be signed ints or unsigned ints or longs or floats or doubles, which kind of feels like we're drifting much more towards C at this point than Python. So again, I think this really depends on what you're trying to work with. And again, it could be very, very specific usage there. Do you have any experience with shifting to arrays instead?
I don't use that a lot. I find most of the time where that's going to fix a problem I have, it's time to go to something like NumPy anyways.
Right.
So I think I would, and I know that's one of his later answers.
Yeah, absolutely.
But, so spoiler alert, but
exactly,
I think I would just skip out. There are specific uses for it,
right.
Particularly if you're getting into like if there are sometimes because the arrays are typed, there are corner cases where you want typed code in the list and you don't want to be able to put something non-typed in it,
right?
But even then nowadays the answer to that is MyPy and things like that. So
right, you get into type checking and kind of constraining things that way. So number 2, which I skipped over, was storage versus memory, and using mmap. Memory map files allow you to treat disk storage kind of as if it were memory, speeding up access time to larger files. We got much deeper utilities on mmap, a tutorial and a course that you yourself did, which you're like, don't make me try to remember all of that in the course.
It's brilliant, I'm sure. Just don't ask me what's in it.
He talks about the LRU cache decorator from functools and it caching expense and function calls, avoiding redundant computations, using LRU, which stands for least recently used strategy. And again, I have an article plus course on that, which Mr. Trudeau also did. And then here's a couple ones that I think are a little more straightforward. 6, which we mentioned, which is use libraries. Hey, that's why people are using things like NumPy and Polars and other tools that are out there that can really, these are often written not in pure Python, they're maybe written in Rust or C or something like that. And so they can work at a lower level to kind of speed things up. Another one that you hear all the time, maybe avoid using loops or ways that you can optimize them through vectorized operations. Again, libraries like NumPy and stuff like that make operations of that stuff much more simplified. One that I've talked about a little bit, or that we definitely have talked about in tutorials that we have, is the idea of short-circuiting conditionals. And this kind of comes back to the idea of really structuring your code in a way that makes sense so that the path that the code is following down could be short-circuited. You can stop checking and exit a very long function or call or some other kind of thing if you find, like in the case of or, you could find that, oh, any of the variables are true, exit, and if any of the variables are false, exit, so there's these kind of techniques you can use by using the advantage of the short-circuiting conditionals, so creating a fast path for your code.
Yeah, I don't know whether it applies in Python. It might, but when you get down into things like C code as well, your CPU is doing predictive fetching.
Yeah.
So your short circuiting can also help in the more likely that you branch, the more likely that the CPU has to go and fetch new code. So there's a style of coding that allows you to be more likely to use the cache, which of course can make a big difference in your code. Python's another layer of abstraction up from that. So it would still be going on at the bytecode level, but I don't know how well that maps between Python code itself. But the principle's the same, right? You're trying to make the computer work less hard.
Yeah. There is a final PS. His PS is saying, check your performance. He's mentioning Perf Profiler there, which I don't know. Having talked to some other experts, it sounds like there might be some other tools that are a little more advanced, to kind of give you a better idea of what's going on inside them. Again, see the conversations I've had with Pablo and Mr. Berger about that stuff before you start modifying your code. But it's an interesting set of tools. I like that it's kind of all gathered together. Again, the examples are kind of small. They kind of just give you a glossary idea of it. So if you want to do a deeper dive on it, I'm sure we got plenty of resources for you here at Real Python to cover any of these topics to go further for you. So what's your next one?
I've got something by somebody who goes by Che, and it's called Python's Preprocessor. So some programming languages have a pre-compile step that typically does some lightweight sort of search and replace, copy paste kind of thing. So for example, in C, if you define a macro, the preprocessor goes through and replaces all uses of that macro with whatever defined code that is. So you'd be forgiven if you thought Python didn't have a preprocessor because, well, technically it doesn't, but there are ways to make it behave like it does. So everything I'm about to tell you is a bad idea. Just because you can hook certain things doesn't necessarily mean you should. So now playing around with this stuff will definitely give you a better idea about how Python turns your text into actual code and codecs and other things, but you're definitely in the realm of there be dragons, and it can result in some hard to understand and hard to debug code. If I remember correctly, we've talked about in the past, there's a joke library out there that allows you to add curly brackets to Python.
Right.
It uses these same kinds of shenanigans. So as a total aside, shenanigans isn't a word I normally use, but it's rattling around in my brain because this post is on a site called pydong.org, which has the descriptive subtitle Pydongery and Other Shenanigans. So
yeah.
Anyhow. So the hook that kicks off the magic here comes from PEP263, which allows you to put an encoding comment at the top of your file. This typically gets used to indicate that the file is in something besides UTF-8, Or more accurately, it used to get used in Python 2 to force a file to be in UTF-8 before that was the default. The hook allows you to specify whatever codec you like, which of course means you can write a custom codec, which gets to do the text interpretation, which gives you this sort of entryway before Python sees the code. The other part of this entry point to our shenanigans is a .pth file, sometimes called a path file. These can be put into your site package directory, and it gives you a way of loading a package when the interpreter starts up, which in this case would be the code that registers your custom codec. So a codec's job is normally, when you're not abusing it, to translate from one form of text into another. So going from, say, Latin 1 encoding to UTF-8 and back. What Che does here is he uses this to extend Python. So the example presented is to add unary increment and decrement operators. That's the plus plus and minus minus you see in a lot of languages who have C as their grandparent. There are a variety of ways of tackling this problem, but it all boils down to using the codec hook to find certain patterns in your code. And then when the codec decodes the code, it returns a string that has copy and pasted in a valid Python string for plus plus instead. The post actually doesn't go into details about exactly how to tackle this. Rather, it points you at source code for libraries that use this trick. And it then goes on to show you other things that can be done with the preprocessor, including that brace bracket trick I mentioned earlier, as well as embedding non-Python languages into your Python, because you could decode some C and then translate it into Python if you wanted to, or hook out into something else. Like I said, dragons. So not something here that you want to do with your production code, but definitely a neat thing to play with and helps you sort of better understand Python internals and codecs. So a fun little afternoon distraction, if nothing else.
Yeah. Go play with internals.
Yes.
This week, I want to shine a spotlight on another Real Python video course. It's about a topic I mentioned earlier in the show as a way to improve performance of your code. The course is titled Python mmap, Doing File I/O with Memory Mapping. It's based on a tutorial by Luke Lee. And in the video course, my co-host, Christopher Trudeau, takes you through what kinds of computer memory exist. What are the types of problems that you can solve with mmap? How to use memory mapping to read larger files faster. How to change a portion of a file without rewriting the entire file. And how to use mmap to share information between multiple processes. Python's mmap provides memory-mapped file input and output. It allows you to take advantage of lower-level operating system functionality to read files as if they are one large string or array, which can provide a significant performance improvement in code that requires a lot of file I/O. So if your projects often read files into memory, I think this course is a worthy investment of your time. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So we do have a discussion topic this week, and it's something that you have a lot more experience with, which we'll kind of dive into. But I did kind of find a few different ideas to kind of get into, but it's all about estimation, and it kind of goes a little further on the list of the habits of great software engineers article, right?
Yep. So the conversation comes out of two different articles. The first one's from Nat Bennett, who we've talked about several times, and it's called You Don't Have to Guess to Estimate. And the second one, as you said, is from The Habits of Great Software Engineers by Vadim Kravchenko. And the subsection we'll be talking about is part 8, which is titled The Art of Approximation. So Nat's article starts out by dividing the word estimate into 3 definitions. First, how much will something cost? Second is guess. And third means like a rough scientific, almost modeling calculation. And the 3 forms definitely overlap. As you know, that guess or rough calculation might be what you're using to get the approximation of a cost, But the subtle differences actually can compound the problem of better estimation, because when the business comes to you asking for one, you might be giving them the other, and that causes miscommunication, right? So Nat goes on to talk from a scientist perspective, where you have a model, you use some sort of proxy measure, and then you use that to perform a calculation on the model. Unfortunately, that often isn't what happens in the software world, where the much simpler ask the devs to guess what it is and add it up is kind of the activity that happens. So Nat briefly talks about preferring the idea of story counting as an estimation mechanism. This is where you take your collection of requirements, you break them down into things that are about even sizes. Usually it's a few days in size, kept in a list, and then you can forecast into the future based on how many of those stories there are, right? So if I've got 10 stories and we're doing about 2 stories a day, then you can look into the future and figure out when those 10 stories will be done. So Nat also recommends a book, which is George DeWindy's Software Estimation Without Guessing, which is now on my to-do read list. Vadam's article is more about approximation than schedule estimation, but these two things do sort of dovetail together.
Yeah.
So he's talking more about like rough numbers. So example, if you're trying to figure out how long it would take 10 gigabytes to get into memory, knowing a couple of rules of thumb and doing some simple multiplication will likely get you close enough for a lot of purposes. To tie this back to Nat's article, this is closer to the scientific idea of definition, with the added acknowledgement that usually a rough version of a model can get you close enough. So these same ideas can be applied to rough out your schedule if you've got some rules of thumb about your schedule. Now, rough estimation is sometimes known as napkin math or Fermi problems. The Fermi in this case is Enrico Fermi. He's a famed physicist who was very good at doing these kinds of rough estimates. One of my favorite stories about this was Fermi tore up some small pieces of paper and let them fall from his hand just as the first atomic bomb was detonated, from a suitable distance, of course. And he used the distance the paper flew and a little bit of back of the envelope approximation involving gravity, and made a guess as to what the bomb's yield was. I've heard several versions of this story wherein there was actually a betting pool and he won. That could be apocryphal, but it highlights the respect that the scientific community have for Fermi's estimation chops.
Yeah.
And in fact, Vadam's article links to a talk on YouTube that covers Fermi problems. And if you're really interested in this stuff, I'd recommend a book called Guesstimation by Lawrence Weinstein. It shows you the rough idea of how to do Fermi calculations, and then it's basically just problem after problem after problem to give you practice with it. So he presents like a few sentences and goes, make your guess, and then tells you what the real is, and then walks you through how to do it. So there's some interesting little stuff in here. For me, I think, one of the things that as developers we always sort of run into is the problem is, I've got a meme kicking around somewhere, which is a bunch of people laughing, and it's like, we'll ask them for estimates and then we'll turn them into deadlines. And I think that's really the core problem we always run into is, how long do you think this is going to take? 3 days. Okay. All right. Give it to me in 2. Well, yeah. All right. So now what? So I know, like, we all end up having to do this stuff, whether it's at the small scale or at the large scale. So maybe, how do you work through these kinds of problems? You've got a boss, they ask for things. What does that look like in your world?
Yeah. The reason I laughed is my wife and I have been watching a lot of Star Trek lately. And I swear that's like the most common thing. It's like, well, how long is it going to take? And the science division is like, well, it's going to be at least, 8 hours or whatever. You got 4,
Yeah. And in fact, I vaguely remember when Scotty shows up in The Next Generation, he's haranguing the engineers, basically saying, no, don't give an accurate estimate, because they'll just cut it in half. You have to blow it out so that when they cut it in half, you can deliver. It's like, yeah, all right. We all play these games.
Yeah, I don't have as much experience in the development circles, and definitely have not done the sort of story optimizing and sort of guessing case there. I have moved into doing a bit more of that when I turned into a remote worker. There's a lot less oversight over what I need to do. And so there's a lot of scheduling for myself to sort of plan out, okay, well, what does my week look like? It's kind of a different sort of time thing that I've had to kind of develop on my own it's unfortunate, but I'm doing less coding than I want to. And so it's like, I feel like I'm a little removed for it. I'm doing a lot more production and reporting and other kinds of things that I'm doing now, and kind of helping manage a lot of these sort of teams. And so it's a little bit of that, I guess that happens to a lot of people, right? They get moved into management positions. So I'm kind of doing a lot more project management than I am per se, like how long is it going to take me to code something out and create it. I appreciate the napkin math stuff that they were talking about in a couple of these different places, and figuring out like a system that you can kind of create your estimates. Again, the napkin math kind of thing. It's like, okay, a really common thing that people would have to do for creating a project. If I were to get more into doing small business kind of work, which I was doing for a little while, to be able to create an estimate for a client to say, well, I think this cloud infrastructure will probably cost this based upon customers, the size of the project, the amount of data that we're dealing with, and then be able to kind of like figure out that sort of stuff and come up with some raw numbers based upon what the going rate is. Of course, that's going to move too. I would say I don't have to do a lot of it. It's just more, it's more time stuff right now and more project management kind of stuff right now. So
Well, inevitably, everybody's always doing this, right? Like, I've got an hour and a half to do this thing before I have to leave the house to meet somebody for dinner. Do I have time to do this? And you know, so there is definitely a sort of like an intuitive aspect of it, where I think organizations run into trouble is that intuitive thing often doesn't scale. So you would think that,
or across a team, right?
Yeah, you'd think that I've got 10 people, I'll ask them all what their intuition is, and I should be able to add it up. And you would hope that statistically some of them are going to overestimate and some of them are going to underestimate, and it might,
you can average it out.
You know, in the wash, it might work out. The reality of is it's problematic. And it's funny because like when I talk about this kind of stuff when I'm doing training, you know, one of those things that always comes up is like, oh, this is going to take me 3 days. Okay. Well, what do you mean by a day? Well, the fact that we even have to ask that question is a symptom of the problem, because I might think this is 24 hours worth of work. And if you left me alone for 3 segments of 8 hours each, I could deliver it to you. But most people's reality is, but there's meetings and these other things. So when I said 3 days, was I talking calendar time or was I talking effort? And if half of us are answering one and half of us are answering the other, that's a problem.
Right.
And then the other thing I find, which is, and this kind of, you know, we joke about it, but the endless optimism of management just startles me, right? So last week, I was teaching a bunch of folks how to use something called a burn-up chart, which includes a predictive cone. And it allows you to sort of look at the performance of a team over time and use it to forecast into the future. How likely are they going to hit a deadline? 3 weeks from now, how much work do we think will be done? You know, to try to answer some of those questions. And one of the reasons I like this chart is it adds probability, because you can say, if the next 3 weeks we do the worst we've ever done 3 times over, then this is how much we'll get done. And if we mix and match some of our best and our worst, this is how much we'll get done. So it changes the conversation with management to be a little more probabilistic. But it doesn't fix the problem. Like one of the managers in the room was like, oh, I love this chart. We'll definitely be using it on the team, but I can never show it to the VP. And I'm like, why not? Because she'll look at the top line on the graph, which is the optimist line, and set that as the deadline.
Yeah.
I'm like, well, yeah, okay. So none of this fixes that problem, right? So like, you know, we have to have reasonable people in the room. And if you don't, it doesn't matter. The other thing I find, you know, when I talk to students about this, one of the things I always just try to push back on is, I don't care how much practice you have at this, everyone sucks at it. And practice can make you better at it, but everyone sucks at it. And recognizing that, and therefore not setting deadlines based on this thing that no human being is good at, is the right way to do it, right? And Nat's concept of, you know, counting stories, what they're trying to do there, which is usually what I try to encourage with my clients, is use data rather than use the estimates, right? So the estimates give you, hey, we've got 50 stories in the queue, but we're actually using the performance of the team. Is the team producing 5 stories a week or 10 stories a week? And so you're using the data of the performance of the team to forecast into the future rather than the guesstimate of just the piece. And that allows you to be a lot more accurate, but it's always a roll the dice kind of thing. It always is.
I kind of want to dive in a little bit deeper. I don't want to make it an entire agile discussion, but that term story is just so foreign to me, and so I wonder about it. Like, is that a measurement depending? It sounds like kind of like a deliverable in a way. Like this is like a chunk of stuff that gets done, but is it going to depend on the size of the team, your employee count, and
It's just a chunk of requirements.
okay, this has to get done.
This has to get done. And there's kind of two different philosophies on it. What Nat is proposing is we try to make sure they're all about the same size. So like if every one of them is about 3 days worth of work and you're going through an estimation process, you look at something and you go, oh, that's not 3 days worth of work. So we have to chop it into smaller chunks, subtract something, move it into a different story.
Okay.
And you end up with a bunch of things that are about the same size. And if they're all about the same size, that allows you to sort of predict the future. There are other ways out there, which is giving it some sort of point count. And the point count really, again, just is a predictive thing, right? So this is a 1 point story and this is a 8 point story. What that tells you is we think it's going to take 8 times as long to do the 8 point story as the 1 point story. So that gives you a little more granularity. And so like you can look at your list and go, oh, we've got, instead of saying we have 10 stories, you can say we've got 40 points. And if the team has consistently been delivering 20 points, then this is going to take them, 2 weeks if it's 20 points a week, right? So it's the same thing. It just changes the granularity of it. What both of them are trying to do is oftentimes in old school waterfall prediction, you go to the developer, you ask them for their estimate, then you go to QA and you ask them for their estimate, then you add the numbers together, and they're not even talking to each other. So you don't know when a bug happens, is the developer expecting a bug to happen? Are they including that in their estimate or not?
Right.
What they try to push with the story piece is it's supposed to be something that is production ready. So the idea being...
Okay, so it's gone through all the steps of testing and whatever.
So when we are estimating that it is about 3 days worth of work, or we're estimating that it's 8 points, we're estimating it together as a team of what would it take to get this thing into production. So there's a little bit of dev in there and a little bit of QA.
Okay.
And so the idea again is to try and get people together and talk about this rather than throwing it over the fence, because the throwing it over the fence tends to be where a lot of the inaccuracy comes from.
So in project management, for the little bit of time that I've been doing it, there's always this sort of step of like creating the buffer inside there.
Yeah.
And I'm guessing that's part of the process too. And of course, the management's going to be like clamping down as far as they can on it, but you're always kind of need something there.
There is the reality of it, and then there's what Agile tells you to do. So
Okay.
some of that depends on how pure your implementation is. The theory says you're not supposed to care. And the reason you're not supposed to care is you're supposed to prioritize the scope. So if we have things in order, the 10 most important things, we're going to get however many we get done this week is what gets done. And if we're pushing to production constantly, and if management gave us it in order, then if we manage to get 8 done, we get the 8 most done. And if we're into a full CI/CD continuous, then that can go out into production. And then the next most important thing will go out there. So that buffer is no longer necessary because the conversations you're having really are predicting the future rather than trying to hit those deadlines.
Okay.
The reality of it is most organizations, there's almost always steps after going to production. It has to go be translated. There has to be marketing materials and whatever. So they always want some predictability because they need to get those things going. So there's almost always some coordination.
Oh, when do we start this process?
Exactly.
Yeah. Okay.
And if you wanted to be really conservative about it, you can start this process once it's in production, and then you would never fail. Most organizations won't do that, right? So then you get into again, we try to forecast it out. And if you're smart, and this is why I was sort of talking about that predictive cone in a burn-up chart, right? So if you look at the list and, if we're pretty consistently delivering between 4 and 6 stories a week, and there's 10 stories in the thing, then I shouldn't say we're going to be done in 2 weeks because there's a chance we're only going to have 8 done. I'm going to be pretty confident that I can do 3 weeks though, because 3 times 4 is 12. And yeah, we'll get 10 of them done in that time period, right? So, but that comes back to my point about being reasonable, right? So if your manager turns around and goes, okay, so give it to me tomorrow, that doesn't fix that problem.
Right. Yeah. That's cool. I mean, it's an interesting topic. I definitely want to include the links to the, not only the 2 articles that we're talking about and the video that was mentioned, but the book that you said, the guesstimation book. So I'll make sure I get that link from you.
For sure.
Does that take us into projects, I guess?
I guess so.
I had a little tricky situation where I'm like trying to figure out when I dug into a particular project. I initially started, I'm like, oh, okay, this seems to be related to a project that Anaconda's doing. And then it kind of didn't. And so I was like, okay, well, what else can I do in this space? And I've been talking a lot about Python and Excel. I had members of the team on it here. Anaconda's connected to that in an interesting way. They provide some of the back end stuff for that and the data science sort of toolkit for people to kind of work with it. And what's interesting is they have a new project that was fairly recently announced that is in this Python Excel space. And I'll include a link to it so you can kind of look at it a little bit more. I'm just mentioning it because it's kind of where I'm leading to. They have something new that's titled Anaconda Toolbox, which is an Excel add-in that makes Python accessible from spreadsheets. And then they also have something that's called Anaconda Code, which I'll read this just from their site, empowers you to write Python code and run it locally directly within Excel. This gives you flexibility control over the Python environment in your workbook, allowing you to add and remove packages as needed, all while keeping code and data securely within your workbook. So it's kind of adding on to some of the features of the Microsoft version of this stuff, but more in the Anaconda world, and then potentially hosting and running it locally. So I'll include links. You can kind of dive and look a little bit deeper there. But instead, I got this email from Chris Lafra about a new project that he's working on that's called PySheets. He scoffed at Python and Excel, and he's like, no, I want to build Excel and Python. And so he's creating something that's called PySheets, which looks really interesting. And I hope to have him on the show to discuss it. And so I'm not going to talk about PySheets directly on this thing, but I'll include a link if you're interested. I'm more interested in this other component of that project that I think is interesting and kind of a little easier to incorporate into one of these little project segments here. It's called LTK, or Little Toolkit, and it's for writing UI structural stuff inside of PyScript. And he's got a YouTube video that explains it in much more detail. It's from PyData Eindhoven in 2023. Along with that video, there's also a demo in something that he's called the LTK Kitchen Sink, which lets you play with all of these, again, UI elements, these widgets live, and you can see how LTK is sort of implemented. It's a declarative Python library that leverages jQuery for DOM operations. And it's actually part of PyScript, which is kind of interesting. At least the PyScript project, if you look it up on GitHub, it's PyScript/LTK, which I think is kind of interesting. And so I think he's going to be working with the PyScript people a little bit more. I think PySheets is kind of his own offshoot and separate project there. He provides code examples in the README for LTK, widget specifications, code examples of creating a UI, such as like a table, rows, headers, stuff like that, styling, and how that kind of connects to CSS and event handling. But it leverages two different things depending on which direction you're headed. MicroPython, which is very, very small and can allow for a very quick loading time. So you can kind of have an instant result if you want to load a page and get a landing page for an application or a project. And then Pyodide, if you want to go much deeper and then load tools like pandas or other things like that. It takes a little more time. I'm very interested in this project. I've been intrigued by, I mentioned last time another project about creating HTML apps. This idea of deliverability of Python applications and not needing to have an installed copy of Python to run it on. The idea of distribution and the web being this great tool for that. So I just feel like this is another potential tool, again, little toolkit in that direction. And again, maybe avoiding learning JavaScript and keeping things Python. So check it out, little toolkit. And I hope to have Chris on to talk about PySheets.
Yeah, and in the notes for LTK, Laffer mentions that he's actually using it on his own web page as well, so you can actually see it in practice if you're curious.
Yeah, that demo is kind of wild. Like, it is a kitchen sink. He's got tab after tab of examples of all these interesting things that you can do with it stylistically, of the types of UI elements that you may want for an application. What's your project?
I've actually got two, and They're somewhat related. They both have to do with the Django admin. So if you're new to Django and you've never heard me talk about it before, I don't know how that's possible. It's a cough, cough, book, cough, cough.
Exactly.
So the Django admin's a microsite built in that allows you to manipulate the database model objects that you've created through a web interface. So if you call back to the blog tutorial that I was talking about earlier, the Django admin allows you to directly edit the contents of, say, your posts objects. It requires very little code, and it pretty much uses the database column typing information that is part of the ORM to figure out what fields you need. So it requires very little to get it going. Project 1 is by Mikhail Pukusa, and it's called django-admin-action-forms. So what the Django admin does well is it gives you a screen that, say, lists all the objects in the database and more screens for editing those objects. What it doesn't have is other ways of creating web interfaces. So if you want to, say, kick off a back-end process, it really isn't meant for that. What Mikhail's library does is provide a series of add-ons for augmenting the Django admin to help you do some of these things. So there's a concept in the admin already called actions, and you can perform actions on a series of objects. So one of the provided ones is delete these objects. But say you wanted a confirmation step kicked off before the action, that would require like some sort of pop-up for a yes/no. And so this library essentially allows you to do that. So simple confirmation form is one of the examples that he gives. You highlight the objects, you say, I want to do the action, and then instead of it just doing it, it will show you a new web page, and then you click yes or no, and then it will go off and do it. So the forms are defined using classes, and then those forms get wired into actions through decorators on Vue functions. So the class contains information on what is displayed to the user. And so, for example, for actions involving multiple objects, you can just add a little attribute called list objects, and it will automatically list all of the objects that the person included in the action, so that there's a bunch of quick and easy sort of things, common tools that you might do in these kinds of situations. And then the actions themselves can also be parameterized, which means when you get to the form, it can have a drop down or some other way of choosing parameters, which then get passed to the decorated view, allowing you to change your behavior based on the actions that were chosen and the parameters that go with them. So there's lots of powerful stuff here, including many different ways of customizing the pages. So if you're a Django admin person and you're always bristling of, hey, I always have to write this custom brand new page, but all I need is this little thing in the admin, this is definitely a library worth checking out. It's been tested in Django 3 through 5, so pretty much any version you want, it's going to be there.
Remy has some really nice examples.
Yeah, he's done a good job of writing it up. It's very, very clear.
Yeah.
Project 2 is by Eduardo Caducos, and it's called django-public-admin. So normally the Django admin is behind a login wall because you don't want random internet people changing your objects. But there's a lot of good stuff here that you might want to display if you need a quick and easy thing. So what this project does is acts as a drop-in replacement for the admin, but its interface is read-only. So the Django admin is not the prettiest thing, so I wouldn't necessarily use this for the general public. But if you're, say, building a tool for devs or it's like an internal thing for your company, this is a really quick way for your users to see everything that's in the database without giving them the power to change it. So the library works by modifying the admin site class, which is just the hook for how Django admin looks at models. The reason I mention this is because Django does allow you to register multiple of these admin site objects. So you could have 2 admin sites running, one of which was read-only and one of which was normal, which essentially gives you the strength of both of those worlds. So neat little project for getting stuff up and running with very little extra code, saves you lots of time, might even allow you to cut down on some of your estimates. So, how's that for a callback?
There you go. Nice. All right. Well, Christopher, thanks for bringing all these articles and projects this week.
Always great.
All right. Well, I'll talk to you soon.
Cheers.
And don't forget, for your time series needs, use InfluxDB. It's trusted by leading companies for its scalability, real-time performance, and easy integration with modern data stacks. Start for free at InfluxData.com. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.